Hello and welcome everyone. Here I am going to introduce you to the mole concept. So write the heading mole concept. Okay, first of all, I'll write the value. Okay, for let us appreciate the scientist who gave this value. It is a Avogadro who gave this value. Okay, and also it is known as Avogadro's number, right? If I want to say that one mole then 1 mole will be is equal to 6.022 or I will write 23 into 10 raised to power 23. Now you must be thinking whether it is atoms, molecules, ions. This is just a number. Okay, this is just a number which we apply in a chemistry. It could be a atoms also, it could be a molecules also, or it could be ions also, right? This number 1 mole which is very big. How much big? If we want to write this, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 16, 17, 18, 19, 20, 21, 22, 23. It is such a big number. Now, what is the significance of this 1 mole? The thing is very clear, or I can say it is used to make our calculations easy. Like, I'll give you a simple example. If you want to buy 12 bananas, or what we will say that give me just one dozen of banana, or 24 bananas, then we will say two dozens of banana, right? 24 means two dozen. From 24, the calculation is becoming to just two units, right? Instead of writing 24, I am writing two. Instead of writing 12, I am just writing one, right? So we can deal with apples or fruits, or what I can say is that let's say I want to purchase some set of notebooks, and I will say give me two dozen or one dozen of notebook or a half dozen of notebook. Let's say six notebook, then it is just a half dozen, right? Now I'll give you a simple thing. I'll ask you one question. Let's say this small block, let us consider this small block of iron, very small block of iron, just weighing something around 2 to 5 gram, or let's take it to be around 5 gram of block of iron. This whole solid thing is made up of Fe. Now can you tell me this very small, let's say this dimension is 1 centimeter by 1 centimeter by 1 centimeter, very small cube of iron. Can you tell me how many dozens of atoms will be there? See, atoms are very small minute particles, and we can't deal with this in dozens, because in very small pinch or in very small work there will be very large number of the atoms, so it's very impossible to say these many dozens, right? Again, even if let us say that in 5 gram there are certain very large value of the atoms, and I get it down to the dozen also, then dozen will be also very big number, right? So that's why we use the mole concept, because very small amount of the things will have a very large number of the molecules. Means every time I don't have to say that this block is having something, I can say 6 0, let's say there is some value 2 3 4 4 8 2 6 7 5 9 4 2 6. Let's say this is the number of the atoms which are present in this 5 grams. I'm just taken this rough value. I don't know what exactly the value, how many atoms will be there in 5 gram. That we will have to calculate. So I'll teach you how to calculate that also. But let us take this at this moment. some value I have taken. This value is not real value. These many atoms, and if I just say that it is just close to zero point 0.1 mole. Okay, if I just say that this is zero point 0.1 mole of iron. Now, which is easy? Saying this easy or saying this easy, right? Saying this is easy because this has reduced my calculation. Now you may not understand what I am saying means why this number is related to zero point 0.1. This is not an exact direct relation. Or what I can do is, yes, at this level, we can understand that very small pinch or a small block of any element will contain very large number of atoms or molecules. So that's why to deal with such a large number, we have the mole concept. And it is equal to 6.023 into 10 raised to 23. It could be atoms. Basically, we use the things for atoms, or it could be molecules or ions. Just take an example. Is it possible for us to calculate, like deal this unit in day-to-day life? Let's say we are going to the shopkeeper's place to purchase, let's say, banana, right? And can we use this unit? Give me this many moles of banana. Can I say this to a shopkeeper? Let us understand this also. Its concept is very simple. This concept is very simple. Let's say we know this relation. 1 mole is equal to 6.022 into 10 raised to 23. And let's say I want to purchase something 100 banana. Okay, I want to purchase 100 bananas. So 100 bananas will be is equal to x moles. And if I do the cross multiplication of this, it will be 1 into 100 is equal to 6.022 into 10 raised to 23. Means I want to find if what is the meaning, how many moles it will be if it is 100 bananas. Then uh, 6.022 into x. So therefore, x will be is equal to 100 divided by 6.022 into 10 raised to 23. Yes. And if I do this, 100 divided by 6.022, I'm getting answer to be around 16.05 into this is 10 raised to 23 in the denominator. When it goes to the numerator, it will become 10 raised to minus 20. Means it is 0.00023 decimal places, then 1605. These many moles it will be. And this is impossible to tell a shopkeeper, and then the shopkeeper will calculate how many bananas, these many moles. It will be a lengthy process. That's why we cannot use this mole concept in day-to-day life. It is applied only for the atoms and the molecule. And this is what the significance of the mole concept is. Further, if I say that, if I say that 1 mole of iron atoms, right? There is one block, okay? There is one block of iron whose weight is, I'm taking this purposely 56 gram, whose weight is 56. Okay, in this iron block, total number of the atoms are present. I can say that it is equal to, okay, maybe this may be confusing. I'll explain this later when I'll be introducing the atomic masses and the molar mass. Just understand 1 mole of Fe atoms is equal to 6.023. You can write this 22 or 23 also. You can 23 is very easy. 6.023 into 10 raised to power 23, because 23 and 23, this is easy to remember. These many atoms of iron, atoms of Fe. 1 mole of, let's say, water molecule. I am saying that water molecule. You understand the difference between a atom and a molecule. Then it is 6.023 into 10 raised to 23 molecules of water. If I say that 1 mole of Na plus ions, right? Then this means that it is 6.023 into 10 raised to power 23 ions of Na plus. And this value, understanding this value is so simple. So I'll end this lecture over here. See you in the next lecture. Thank you.